For number 3, we're still trying to estimate the area under the curve, y equals 9 minus x squared, from negative 2 to 2. This time we're using a right-hand Riemann sum with 8 equal subintervals, and we're going to try and set up a sum in sigma notation and use our calculator to do all the adding. So with this, we can use a formula. We've tried this a different way in class, doesn't seem to work for everybody, so I'm going to show you a different way. Kind of ties it in with the long way that we did the one day to find the exact area. Well, a couple things we need to know. We need to know what delta x is. And delta x is the base of each rectangle. We get that from the formula b minus a over n. So for this one, our b is 2, a is negative 2. So we have 2 minus negative 2, which is the same as 2 plus 2. All over n is the number of subintervals, so that's 8. So we get 4/8 or 1/2. So again, this is equal to the base of each rectangle. Every rectangle is going to have the same base. Now, the height of each rectangle, as we saw in the last problem, the last couple, we got the heights by plugging in a certain x value into this equation. Right, the x value changed for each rectangle, whether it was a midpoint or a left-hand Riemann sum. Right, here we put the left x value in, here we put the middle x value in. In this one, we're doing the right x value. Well, if we look at this, we're breaking this up into 8 equal parts. Each one has a base of 1/2. So we would be going from negative 2 to negative 1.5. That's our first interval. Then negative 1.5 to negative 1. Then to negative 1/2, 0, 1/2, 1, 1.5, and 2. So we've broken this up into 8 equal parts. At least the interval from negative 2 to 2 is 8 equal parts, half of a unit each time. So we have 8 regions, 8 intervals. And the base of each one of these is 1/2. Now, if we're doing a right-hand Riemann sum, that means we're taking the right side of the interval. At that x value, we're looking on the graph, and that's going to be the height of our rectangle. So here, first one is at negative 1.5, next one's at negative 1, then negative 1/2, then 0, then 1/2, 1, 1.5, and 2. So those are all the rectangles we're trying to find the area of and adding up. So each one we're putting in the right x value. Well, to set up a formula, we're going to set up x sub n. And that's going to represent n equals 1, means like the first x value that we're plugging in. X sub 2 would be the second x value we're plugging in. Well, that is going to be equal to a, right, our starting value here, plus n times delta x. Or let's put it the other way around. Delta x times n. Right, so for our first rectangle, we're starting off at negative 2, and we're adding 1 of those delta x's, 1 of those bases. So 1 times 1/2. So we have 1/2 n. Negative 2 plus 1/2 n. So for our first rectangle, negative 2 plus 1/2 times 1, we get negative 1.5. Then for our second rectangle, x sub 2, we're doing negative 2 plus 1/2 times 2. That gives us negative 1, and so on. So this is the x value that we're going to be plugging in for each one of the rectangles, where n represents the subinterval, or the rectangle. Well, now, our equation to set up in sigma notation looks like this. We're taking the sum from n equals 1 to n, right, the number of subintervals, of delta x times f of x sub n. So for our example here, we're taking the sum from n equals 1 to 8. Our delta x is 1/2. F of x sub n means we're going to take this, we figured out what x sub n is, we're going to put it into this equation for x. So that's 9 minus, I'm just going to rewrite these the other way, 1/2 n minus 2 squared. So this is the sum that's going to give us the area of those 8 rectangles added up. It's just the base times the height of each rectangle. So if we put 1 in, we'd get 9 minus negative 1.5 squared. Right? We'd put negative 1.5 in there, square it, that gives us our height, and then times the base. Then if we put 2 in, that gives us the second rectangle. Put 3 in, that gives us the area of the third rectangle, and so on. So now we're going to go ahead and enter this in our calculator. So to do that, we're going to go to Second Stat, over to Math, and then down to the 5th option, Sum. Then we're going to do Second Stat, go to Ops, the 5th option, Sequence. I want to put in this equation, or this expression. So we have 0.5, parentheses, 9 minus, parentheses, 0.5 x minus 2, parentheses, squared. And then I want another set of parentheses to close out all of this. So there's our expression, comma. Next thing we want is the variable, which is x, comma. Next thing we want is our starting value, which is 1, comma. Ending value is 8, comma. And the last thing is the step, how much it goes up by each time. So 1. Right? We have our first subinterval, second, third, fourth, all the way up to the 8th. And then hit enter, and we get an area of 30.5.